Hello, this is David Paik. I'm a sophomore student studying mechanical engineering at Johns Hopkins University, and this is my MBD lab design and build project. For this video, I built a ping pong ball launcher. You see, I love playing ping pong. I used to play all the time with my friends back in school before it was closed down. And now that everybody's isolated and I can't play ping pong with my friends anymore, I thought I could use a ping pong buddy. So I made this guy. So how does this work? Let's turn this thing on first and then see what happens. So let's look at this device in detail. The whole structure is based on this metal basket I found at home, and this is the wooden ramp on which the ping pong ball rolls initially. Then the ping pong ball goes through this paper tunnel. The paper tunnel has two identical cutouts, one on this side and one on the other side. These cutouts are for the wheels to be able to rotate and have contact with the ping pong ball. This is the top-down view of the launcher. The wheel on the bottom had to rotate counterclockwise and the one on the top had to rotate clockwise to push the ball forward in this direction. The motors that spin the wheels are powered by the Arduino. This Arduino board supplies a constant 5V voltage, drawing power from the computer through this USB connection. So that's about it on how the launcher works, and now let's talk about how I designed this thing. I drew inspiration from those baseball machines that fire baseballs to you, and I also remember during last semester's freshman design team project, there was a team that fired their wooden airplane with the same mechanism, so I thought I could do the same thing with a ping pong ball. So my initial thoughts were that I'll first need a track for the ping pong ball to go through, and then two rotating wheels for the ping pong ball to be in contact. For the track, it had to have a pretty smooth surface so that the ping pong ball doesn't roll with too much friction. And I also had to make sure that the ping pong ball doesn't fall off the track too easily. And the wheels had to provide enough friction for the ball when it's firing, so I wrapped rubber bands around the wheels. Probably the hardest part in designing this device was to figure out a way how to keep these two motors at fixed positions while it's operating, and I found the perfect solution with this metal basket I found. It had the perfect amount of spacing to put in these motors, and I reinforced them with glue gun. One thing to note about the wiring is that because the two wheels had to rotate in opposite directions, they had to be wired in opposite ways as well. Since this wheel had to rotate clockwise, the positive terminal on the breadboard was connected to the negative to this wheel, and therefore the ground on the breadboard was connected to the positive terminal. And finally, I attached this ramp made out of chopsticks at the very end so that I could just put the ping pong ball and it would roll in rather than me having to push through the tunnel. Now, let's talk about some aspects that I think this device can improve on. First, I think this device will be better if I was able to control the motor speed. I hope that this device can be used for ping pong players of all levels. So maybe some people will want the ball to be fired fast, and some people will want it to be slow. If I had a transistor and a couple of potentiometers, then I would have been able to control the motor speeds. I could have even controlled individual motor speeds so that I can alter the path of the fired ball any way I wanted to. I could have also used a stronger voltage source. And another thing that I want to talk about is I perhaps wanted to automate this even more. Maybe I could have had like a basket full of ping pong balls here and then have the balls fall one by one and then they'll be fired one by one automatically so that I don't have to put the ping pong ball on the ramp all the time. I also wish I could have soldered the wires to the motors because they kept falling apart and I had to tape them constantly, but I didn't have the right equipment at home, so yeah, that's that. And lastly, I wish I could have used a clear plastic tunnel rather than this paper tube, because if I used a transparent tunnel, then I could have seen the ball go through, deform slightly because of the wheels pushing through it, and if I could get that footage on slow-mo, that would have been way cooler. So that's it for my video on making this ping pong ball launcher. Thank you for watching, and I hope this was helpful.